All right, problem 5 says, consider the family of functions f of x defined as 1 divided by the quantity x squared minus 2x plus k, where k is a constant. For part A, it says, find the value of k for positive value k, such that the slope of the line tangent to the graph of f at x equals 0 equals 6. So let's get started with part A. Basically, we're wanting to figure out what would k have to be for f prime of 6 to equal, or no, sorry, f prime of 0 to equal 6. So let's take f prime. You could use quotient rule, or you could rewrite f as x squared minus 2x plus k to the negative 1, and then just use chain rule, which is my preference in this situation. So f prime would be negative 1 times x squared minus 2x plus k to the negative 2, and then multiplying by the derivative of the inside function would give you something like this. So I'll just clean it up real quick. You'd have x squared minus 2x plus k quantity squared in the denominator. And then when you multiply negative 1 and 2x minus 2, you get basically positive 2 and negative 2x. So that's a version of what f prime of x could look like. And now let's figure out, let's use this initial condition. It says slope of the tangent line to f at x equals 0 equals 6. And so that means that f prime of 0 is 6. So going up to f prime, that means if I put 0 in for x, I should get 6 out. So I'd get 6 equals. On the top, if x is 0, I'd get 2. On the bottom, if x is 0, I'd just get k squared. And now we just have to use some algebra to solve for k. So I'm just going to multiply both sides by k squared. And then divide the 6 over. And then square root. I'm not going to worry about plus or minus, as I said k has to be positive anyway. So k would equal, and you could say square root of 1/3. You could say 1 over square root 3, or you could say square root 3 over 3. These are all considered correct answers. So if you got any of those, then you're good. So that's it for part A, I believe. Now for part B, it says for k equaling negative 8, find the value of the integral from 0 to 1 of f of x dx. So let's get started on that. So first, let's let k equal negative 8, and we'll just substitute that in here. And then I'm going to take that rule and put it into this integral. So we're basically trying to evaluate the integral from 0 to 1 of 1 over x squared minus 2x minus 8 with respect to x. And then from here, I would use partial fraction decomposition on that integrand. So 1 over, actually let's factor it. X minus 4 times x plus 2. And then the form and then I'm going to jump to the part where I'm setting the numerators equal to each other. And so we'd end up with a plus b needing to be 0. I think I'll go over here. And 2a minus 4b would have to be 1. So solving this, totally up to you how you want to do it. Row 1 says a is the opposite of b. And row 2, then, I could write it as 2a plus 4a equals 1. And then I'll just solve for a. I'll get a equals 1/6. And b is negative 1/6. Okay. So now that I have those, I could come over here and rewrite the integral as the integral from 0 to 1 of 1/6 over x minus 4 minus 1/6 over x plus 2, like so. And then you could use substitution or whatever works for you for getting the integrands here. But I basically end up with 1/6 times the natural log of the absolute value of x minus 4 minus 1/6 times the natural log of the absolute value of x plus 2. And since I have bounds, the plus c would subtract out. So now let's just plug in the upper bound. So plugging in the upper bound, I'd have 1/6 times the natural log of 3 with those absolute value marks minus 1/6 times the natural log of 3 again. So that's kind of cute. Those vanish. Then we'd have minus 1/6 times the natural log of 4 and plus 1/6 times the natural log of 2. And then these would vanish, like I mentioned before. And so, let's see, we'd end up with, you could write it like this. And you're right. You could also use some properties of exponents to clean it up, but I don't know why you would if you're being timed, but just so I can show that it matches up with what the solutions on the College Board had. You could use the power property for logarithms, multiply the 2 by the 1/6 and get this. And then 1/6, actually I'm going to write that as just 2/6. And then you could add these up. So we get negative 1/6 natural log of 2, which I think that's what the College Board had, but we were correct back here as well. Okay, now let's look at part C. Part C says, for k equal to 1, find the value of the integral from 0 to 2 of f of x dx, or show that it diverges. So if k equals 1, we'll just put the 1 in there and then put it into the integral. So let's look at what we've got. And then let's factor the denominator. Like that. So let's think graphically for a second. This function right here has a vertical asymptote at 1. So let's say 1's here, 2's here. So graphically speaking, you know, it looks something like this. So we have an improper integral. So your graph, we're going to have to split it into 2 integrals, one going from 0 to 1 from the left, and one going from 1 to the right to 2. So let's look at that. So this would be equal to like so. And then we could do, you know, u substitution, and the same u substitution would treat both of them. So u is equal to dx. And so we'd have, I'm also going to fix the improper piece. So limit as b approaches 1 from the left of the integral from, how do I want to do this? Blah, 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 blah. Do I want to change my bounds? I guess I kind of don't. Let's see. Let's just do the, let's do a note. 1 over x minus 1 squared dx 2. Which power rule that thing? Add 1, divide by the result. So there's the antiderivative. So I'm just going to go ahead and put that in. So we'd have negative 1 over x plus 1 dx from 0 to 1 from the left. Oops, 0 to b. Plus the integral from, oops, the limit, I'm going to call it as a approaches 1 from the right, integral from a to 2. Oh my goodness, I already did the integral. What am I doing? Sorry. All right. Thank goodness this pen's erasable, right? Okay. There we go. Okay. So we'd have limit as b approaches 1 from the left of -1 over b minus 1 plus 1 over plugging 0 in would give us -1 plus the limit as a approaches 1 from the right of -1 over 1 from plugging the 2 in, and then plus 1 over a minus 1 from plugging in the a value. Whew, okay, now let's see what happens. Let b approach 1 from the left. So like this right here would be -1 over 1 from the left minus 1. So this is like a 0.9999999 deal. Take away 1, you have something really close to 0 but a little bit negative. So you have a negative divided by a negative, so you have positive infinity from this piece here. So this is equal to infinity, and then we're subtracting 1 from infinity right there. And then over here we have -1, and let's figure this out. You're letting a approach 1 from the right, so that would be positive 1 on top this time. So we'd end up with positive 1 divided by a little tiny positive, so you get positive infinity again for that part. All right, so what do we have? We have infinity, take away 1, plus infinity. All right, 2 times infinity, take away 2, which is infinity. And that is the long version of saying that the integral diverges. There we go. All right, sorry for the mistakes. I hope that makes sense.